The equation given here has roots alpha and beta. Without solving this equation, form a quadratic equation with integer coefficients which has roots alpha plus 1 over beta and beta plus 1 over alpha. Okay, I've got the question summarized here then. So let's have a look at this. This equation can be written as x squared minus 7 over 2. I'm dividing by 2 all the way through, plus 2 equals 0. Now, if it's got roots alpha and beta, we know that x minus alpha times x minus beta will equal 0. Now we can make the correspondence because this is just x squared minus alpha plus beta, isn't it? Lots of x squared, minus beta minus alpha x, which we can write like this in a bracket, plus alpha beta. So now we can read off the correspondences. We can see, so this value must be alpha plus beta, mustn't it? Because the minuses are both there. And the other thing, the alpha beta, is equal to 2. Okay, now we want roots alpha plus 1 over beta and beta plus 1 over alpha. It has roots. Okay, how are we going to do this then? Okay, well first of all the sum of these. Let's look at this. So here, let's have a look at this. I'm going to have a look at this equation first. So if it had roots this, x minus alpha plus 1 over beta, there's the first root, and the second root would be x minus beta plus 1 over alpha, wouldn't it? So we want to form the quadratic, so we'd get x squared here, we'd get minus this and minus that, so minus all of them together, so minus alpha plus beta, just added them all up, plus this plus that. Now this fraction we could write as alpha plus beta over alpha beta to save some time. Can you see that? 1 over beta plus 1 over alpha. Cross multiply alpha plus beta over the product alpha beta. So those two can be put in this form. Okay, so we've got that. So that would be the sum times the product plus, minus times minus, and then we've got this product here, which I could times by. Just let's expand it, alpha beta. Then we've got alpha times 1 over alpha is 1, beta times 1 over beta times beta is also 1, and then we've got 1 over alpha beta. So there's the constant equals 0. Okay, form the quadrant which has roots this. So basically we need to put in these, so we see that, what have we got then? We've got x squared minus alpha plus beta is 7 over 2 plus alpha plus beta is 7 over 2 over alpha beta, which is 2, close bracket, lots of x, I should have written x here, shouldn't I, plus alpha beta, which is 2, plus 2, plus 1 over alpha beta, 1 over 2, equals 0. So that tells us then that x squared, this is 7 over 4, plus 7 over 2, this is 14 over 4, plus 7 over 4. 14 plus 7 is 21 over 4. Lots of x. There's an x in here, which I keep missing. Plus 4.5, 9 over 2. Equals 0. So what does the question ask for? Without solving this equation, form a quadratic equation with integer coefficients which has these roots, which is what we've done. Just looking at this here, everything is okay except I forgot. So I've just been looking at the question just to check I've got it all right. And of course that's a minus there, isn't it, as the final answer.